10.1 Exponents, starting off our chapter with standard 8EE1, where we can develop, use, and apply the properties of exponents to simplify expressions. But today, we're going to start off with these three words, vocabulary. We're going to deal a lot with power, base, and exponent. So that way, once we get a clear grasp on those, we can build our way to these skills and also talk about the rest of these vocabulary. So let's start off with our vocabulary for today, talking about a power. Power is a product of repeated factors, something like 2 cubed. So we are familiar with things being written like that, but now let's talk about our vocab for today. When we talk about it today, we're going to talk about the base. The base is the repeated factor of the powers, so that's the bigger number, the base, the bottom, however you want to refer to that. The base is the repeated factor, and then the exponent, using our technical terms with our tending to precision with our vocabulary, exponent is the number of times that the base is used as the factor. So that would be the tiny number up here, sometimes referred to as a power, but we're going to call it an exponent. So base of 2, exponent of 3, which means we need 3 2's to figure that out in evaluation, but we'll get there. For right now, read instructions. Sometimes they say evaluate, which means we want an answer, and other times they just say write the product using exponents. In this instance, writing the product using exponents means what's being repeated. That's your base, the 4. Then you have your exponent, how many times. Count very carefully. 1, 2, 3, 4, 5. Whether you're on computer, on your book, whatever you're using, please be very careful you don't mark up your computer screen or your textbook. And it is important, 4 to the 5th is the right answer and the final answer on this problem. Any other exponent, you got close in counting, but it is not correct. So attend to precision, count once, maybe count twice. This example, we've got 2 things repeating. The first one is -2. Do note it is in parentheses. Please keep it that way. There are 2 of them. And then the other thing repeating, the other base that's being repeated, the other factor would be that x, and again, count very carefully. 1, 2, 3, 4, 5, 6. This is the final answer, and yes, that -2 needs to be in parentheses. It's important. We'll talk about why in the next slide. Last one, doesn't matter how many factors there are or bases. Again, here we start off with that the x becoming squared because there are 2 of them. And even though they've included pi, it's just another factor, so make it a base. 1, 2, 3 of them. That's it. Done. When doing a book assignment, please make sure that you write down the original problem, so everything that you see here, as well as your answer. That needs to be done for the book assignment. Again, now it says to evaluate. Here's where we want an actual answer. These can be typed into your calculator, but you must do exactly as you see it, and it's very important because the final answer on this one must be the -27, and here's how that works. The exponent tells us how many factors we need. We need 3 of them, so I can put 3 little blanks. And the base, the factor that's being repeated, is -3. So you could put that into your calculator, -3 times -3 times -3. Also very helpful to write it out and then multiply it out in your calculator or using mental math. Again, be very careful, attend to precision. Remember, 2 negatives give you a positive answer, so that's a +9. And a +9 times a -3 gives us a -27. Final answer. That's how it is. So if you see parentheses, you need them. On example B, there are no parentheses, so this is very important. Watch the small difference here. The exponent is 3, so we need 3 of the base, but the base is just the 3. It's not actually a negative. That's little negative on the outside is actually read as the opposite. So we want the opposite of 3 cubed. 3 cubed is 3 times 3 times 3, which gives us our 27. And what is the opposite of a positive 27? It is a -27. With the odd exponents, not a big deal because it doesn't change very often, but with the even ones, we must be very careful. For example, down here, -4 squared, sometimes we'd say is 16, but again, this one is unique. The 2 means we need 2 of the factors, and that factor, that base, is just the 4 because it's read as the opposite of 4 squared. So it's like there's a parenthesis there, the opposite of 4 squared. So 4 squared is 16, but the opposite of it is negative 16. The only right answer for C is a negative 16. Be very careful. Here we go with this one again. 4 is an exponent, writing it out. The base is the repeated factor, the thing in the parentheses, which is a negative 5. Typing it into your calculator or doing it with mental math, either way. Mental math, this gives us a positive 25, and these two give us a positive 25. Multiplying those on out, 2 positives gives us a positive 625. Watch the parentheses and the exponents. Those are things that can get us to make a little mistake on our assignment. Remember, we're doing this because we're looking at these words here. Power, base, and exponent. So we'll talk about your standards. You can put a check mark by those because that's what we're working on today in mastering, so that way we can get over here to these other skills that we'll be building on in the future. Evaluate. So again, we're just going to evaluate it. Possible to put it into your calculator, but please remember PEMDAS is something you and your calculator both must do. But with PEMDAS, please remember, put a bracket around the M and the D. They go together. So sometimes we've got taught wrong, we remember wrong, whatever it is, don't do multiplications first, then division. Work left to right. Same with addition and subtraction. Those go together, so I usually just put a bracket around them. And remember that you go left to right. Don't do all of the addition first and then do subtraction. Start on the left and work your way to the right, doing whatever you see first. So in this instance, there are no parentheses in example A, so I'm going to cross off the exponent. 5 squared gives me 25. And then no more exponents, so I'm going to move right along. I'm looking for multiplication and division, starting on the left and going to the right. First one I see is right here. That 4 times 25. I'm just going to cross that on up. That makes 100. And then bringing down that 2 and the subtraction, be very careful not to lose that. Or sometimes we would have switched that to adding the opposite, so we would have remembered that's a negative 100. So 2 minus 100, or 2 plus a negative 100, either way, you get a negative 98. Second example, remember PEMDAS, no parentheses. All right, moving on to exponents. Here it is. I'm going to cross that guy on out. 6 squared is 36. You can see from before, I showed my work, but I didn't rewrite the problem. If you would like to rewrite each step, you are more than welcome to do that. Otherwise, I just showed my work like the last one. Since I've written it out this way, I'll continue showing my work. There is no multiplication or division. So now I'm going to work on addition and subtraction, but I'm just going to start on the left and work my way to the right. So I do these guys first. Gives us a total of 41. And please note, whether you have switched this to adding the opposite or you have left it as minus 4, whatever it is, 41 minus 4, 41 plus a negative 4 gives you a positive 37. Evaluate them away, show the steps, write that original problem if you're doing a book assignment, and then we've got one of these. I just want to review quickly. These lines are the absolute value. Absolute value is the distance from 0. I've also said that it's always, 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 always positive. Start on the top. Please remember, this is saying the opposite of 3 cubed. So we've already done that before. We take 3 times 3 times 3, and then we want the opposite of that. So that gives us a negative 27 over that positive 27. And then I'm going to throw those absolute value lines in there so we can see that. A negative 27 divided by a positive 27 gives us a negative 1. And then we've got those absolute values. The distance away from 0, that negative 1. That's the absolute value. It's 1 away. Distance is always, always, always positive. Thus, the absolute value of negative 1 is always, always positive. It's going to be a positive 1. Remember that with absolute value. Last one here, we've got a word problem. In sphering, I don't know a lot about sphering. I know a little bit about knockerball, but sphering is where a person is secured inside a small hollow sphere. So that's right in here is where you get secured. Then you're surrounded by a larger sphere, so that's the one out here. The space between the spheres is then inflated with air, so all of this gets some air inflated in it. And then it says, what's the volume of the inflated space? To find this, we have to go back to like we did before in the previous chapter and find that negative space. So we have to find the volume of a sphere twice and subtract them out. Because we need to deal with that larger sphere. Please remember our formula for a sphere is 4/3 pi r cubed. That is the volume of a sphere. Be very careful when we talk about that r. That r stands for a radius. That is part way from the circle. So that's from the middle to the outside. So working with that big one, be very careful that when we type it on in, we're going to do 4 times 3.14, that's our pi, times our radius, which is not 3, it's going to be 1.5, and make sure you cube that, and put that all over 3. When you type that into the calculator, remember what we've done before to help us out. We type in that top, the numerator, 4 times 3.14 times 5, 1.5 cubed, hit equals, and then divide by 3, which will give you the answer, 14.13. Came out nice. And then let's do it again for the smaller one. So formula, 4/3 pi r cubed, where we're going to take 4 times 3.14, and be very careful again. Please remember, we are dealing with a radius, which is from the middle to the outside. If the whole thing across this inside is 2.2, all we want to know is what half of that is. So we're going to plug in 1.1 and cube that. And then when we're done with that, don't forget to divide it by 3. So again, take that numerator, type that all into your calculator in one fatal swoop. If you don't have a calculator that does these powers over here, then please make sure that you type in 1.1 times 1.1 times 1.1, then times 3.14, then times the 4, hit that equals, so that way it takes care of PEMDAS correctly, divided by 3. That one does not come out quite as nice, so what you'll find us doing is we'll round that to the nearest hundredth for this example. Oops, switch to the crayon on accident, apologies. So then we got the larger one up here, the smaller one here. We want to find out what space was inflated. We want to find the difference between those two. So we're going to subtract those guys on out. Put a little subtraction sign there, or you are welcome to rewrite it. You can do that. 14.13, 14 and 13 hundredths, minus 5 and 57 hundredths, gives us a final answer of 8 and 56 hundredths meters. And remember, volume is always going to be cubed. This one comes on into play because you can see from up here, our formula had that exponent on it, the cube. So we're dealing with that in our formula and working with that, getting the answer down here. Make sure you show the formula work answer and label as before. This all was, again, starting down here with our vocab, power, base, exponents. So you can put checks by them, lines through them, whatever it is that you're doing. Those are the things we've covered so that we can get to the standard up here with the skills that we need in future lessons. So today our goal is that I can write expression using integer exponents and that we can evaluate expression involving integer exponents.